Let's talk about molar masses. What the molar mass is the mass in grams of a mole of whatever compound, substance that you're talking about. So let's look at a compound like barium nitrate. We've just gone through an exercise in an earlier video to determine the number of each type of atom in barium nitrate. Now we've got one barium, and we have 2 nitrogens and 6 oxygens. That parenthesis subscript 2 means we multiply all the atoms inside it by 2. And we're going to use the periodic table and the average atomic mass for each to come up with the overall mass for this compound. So we got one barium at 137.33. We got 2 nitrogens at 14.01 each, which gives 28.02. And we have 6 oxygens each at 16. So if we add those all up, we'll come up with 261.35. We're talking about a mole, that's going to be grams per mole. If we've been talking about a single formula unit of barium nitrate, if we could have just a single barium atom and 2 nitrate groups associated with it, that would have been 261.35 AMU per formula unit. When we're talking about a mole, barium nitrate is 261.35 grams per mole. Avogadro's number is what it is. It's because of what it is, it allows us to use the same digits for either a single unit or for a mole of it. But all we have to do is change the units appropriately. How far do you carry out these significant figures? Oftentimes just going to the hundredths place will more than suffice in giving you the number of significant figures that you need. We have mass spectrometers nowadays that can give us masses out to 6 decimal places even. And you could use all those decimal places if you wanted to, but that's just extraneous effort. That's really not needed. Most of the time, just going out to the hundredths place will more than suffice. Let's do another one. Let's do acetic acid. We count up the atoms. We've got 2 carbons, and we've got 3 plus 1 are 4 hydrogens. We've got 2 oxygens. And so we'll multiply those by what we see on the periodic table. Carbon is 12.01 grams. Hydrogen is 1.01. And oxygen is 16.00. So they give us 32 for oxygen and 4.04 for hydrogen and 24.02 for carbon. We add all those up. And they give 60.06 grams per mole for acetic acid. So we've looked at barium nitrate and we've looked at acetic acid. And so being able to calculate the molar mass is important.